Alright, folks. Time to have an adventure in Godot, the free open source game engine. Alright. You have chosen 3D. So, we are making a 3D game now. This is, we only have about an hour, so I'm not going to explain everything. But hopefully you can spark some interest in watching the process. So, Godot is made of. In Godot, the game is made of nodes. These are things that exist in a place, and they do things. So, they come in a hierarchy. So, first we got to create our root node. We're doing 3D, so we're going to click this. So, this is our root node. I'm going to rename it world. So, everything in the game is going to be a part of this world. And we do that by adding a child node. So I'm going to do CSG box. Alright. Die. Okay. So our world node has a child, which is this box. Let's make it a little bit bigger. So we've got this box. And so if we move our world node, we see the box moves with it because it's a child. And then if I were to move the box relative to the world, then I rotate the world, you see it's sort of rotating on the axis of... We're rotating the entire world, so if we were to put like, something else in here, little pillar, right? Then we rotate the world. You see, everything rotates with it because both of the boxes are children of the world node. So, hope you can understand that a little bit. We will proceed making some sort of 3D environment to walk around in. I'm using these CSG boxes. They're a type of node, a type of 3D node that allow you to construct shapes dynamically, you know. You don't have to break out your modeling tool. You can just sort of slap them together. It's good for prototyping, though it can be a little performance heavy when it comes down to big worlds. So I'm going to make another. Let's make a room. Big old room. Splonk. Alright. Let's see. I'll make a doorway into our room. By doorway, I mean just like empty doorway. I don't think we'll have time to do actual doors. We'll see. So I'll call this one round because we'll probably want to click on it a lot. I'll make it a bit bigger. Alright. I'm going to select all these, make sure they have collision. Alright. I'll save this. I'll save our scene. Scenes are saved in Tuscan files, TSCN. I'll call this FPS game. I'm going to make sure our project is going to run this. Okay, next thing we need in our game is a camera. Camera. There's a 2D camera and a 3D camera. 3D stuff is red, you see? So, the camera, you know, it's just like in a movie. It shows what's in the game right now. And it's awfully tiny. I might want to scale my world down a bit. Like that. Alright. Whoop, doop. Camera goes down here. So now we can click on this to see what the game looks like from the camera's perspective. I'll just give it a bit of rotation here. Yeah, let's run our game, make sure it works. Look at that. There we go. So, just to make sure we can tell the wall from the ground, I'm going to add a material. Material describes what a thing looks like, how the lighting interacts with an object. So, just going to make a dark gray one. It's going to be a stone. I'm going to save it to a file. I'll call it basic stone. And our ground needs material. You know, we're not walking on blue Play-Doh. We're walking on grass because, well, I mean, that's what we want, I guess. Maybe you prefer to walk on dirt, or like, walk on magenta weirdness. I'm getting sidetracked. So, got our camera. So, do you folks want to make a first-person shooter or a platformer? That's a rhetorical question because this is a recording. So, we're going to make a first-person shooter. So, what you do with the first-person shooter, the camera is sort of inside of the player while the player is walking around. So, we need a player. So, what I'm going to do is I'm going to add kinematic body. That's okay. I'm going to call it player. It doesn't have anything to look at because this node, the kinematic body, is for physics. It's not for like displaying things to the screen. And so, because it's a physics thing, it needs a collision shape. So that defines, defines mathematical shapes that the physics engine uses to tell if something's hitting it or not, like a hitbox. So player characters are usually represented by capsules because that allows them to go up slopes easily. Gonna rotate it upright and change the size. Just want to bring them down here, make sure it fits in a doorway. Quote unquote doorway. Yeah, okay. That works. Alright. So, now we want our camera to be attached to this player. So, we're going to make the camera a child of the player node so that it moves and rotates with the player. Right. Yep. And so now if we move the player, the camera moves with it. And if we rotate the player, the camera does move. However, it's moving on the wrong sort of axis, right? We want it to be in the center of the player so that when the player rotates, the camera rotates without moving. So I'm going to reset this transform here for the spatial object. So camera is a spatial node. Spatial nodes are what Godot calls, 3D nodes. And it has this property called transform, and that just describes the 3D position, orientation, and scale. Scale is the size of the object, right? So we want to reset translation and rotation so that the camera is at the origin of the player. It's a child of the player, so the origin of its coordinate system is the center of the player. So now we want the camera to be a little bit higher up because it's, it's sort of a abstract representation of your eyes. So we want to put it at about eye level, like this. And so we run the game, I mean, same crap, because we didn't really tell it to do anything. So, you gotta make things do things. So, how to do that? You see, we use the script. We can create a script here and call it player. Sure, player. I'll call it FPS player. All right. So script is a code file written in GD script. This is Godot's own programming language for its scripts. You can also use C# if you set up things differently. Godot's scripting language is a lot like Python, and so you may find it easier to pick up than C#. So this isn't a coding tutorial. We don't have time for that, but I'll try to describe generally what I'm doing. So func process. So this code runs every frame, and this delta is a number telling you how many seconds have passed since the last frame. So we're going to go... Alright. So our player is a kinematic body, and this means it's a physics object that moves without following the laws of physics. So you move it yourself with the code instead of using the physics engine. However, it still collides with things and interacts with the physics engine. So we gotta do this to make sure that the player isn't just like rolling around on the floor. You know, we don't want too realistic physics. We want physics that we can control so the player can move smoothly. But I digress a little. So we do that with this function called move and slide. It takes a number of parameters. This here is linear velocity. It's a vector 3, so just 3 coordinates x, y, z in the mathematical coordinate system. And yes, the rest of this is whatever. So I'm going to put a placeholder name in here. I'm going to specify that up is up, because of course it is. And one of the stop on slopes, why not? We don't have any slopes at the moment, but who cares? So velocity, doesn't know what velocity is, we got to tell it. So up here we declare our properties of the script, right? So velocity, for instance, we'll say it's a vector 3, set it to 0. You can do it like this. So velocity is going to be how much the player moves in units per second. So yeah, we can simulate gravity, right, by decreasing the velocity on the y-axis. So here's the y-axis, it's the green arrow pointing up. So if we increase the y, then player goes up. Decrease the y, player goes down. Velocity.y, we're going to subtract from it so it goes down. And we need a number here. So velocity is how much the player is going to move each frame. It's the change in position. And so we need to change the velocity. So the change in velocity is called acceleration, if you've taken one of those courses, right? So we'll call this gravity acceleration. We'll call it 100. So this is how much the velocity changes. We'll multiply it by delta. That just makes sure it's synced with the timing of the game. All right. So now, well, you probably didn't notice. I'm going to bring the player up a few bits. Notice how the player starts to fall, and let's decrease this acceleration so you can see he falls faster the longer he's falling, because the velocity just keeps decreasing and decreasing. So I'm going to change that to 50, 100, I guess. Alright, so now we got to move around. So this requires, using the keyboard or something. So project settings. This is where you configure what keys do what. You can see I already have some set up for walking around. Walk forward is WSAD, like a first-person shooter. So going to go in here, and I'm going to say if input is action pressed. So that menu we just looked at, we define an action, we give it a name, and then we assign keys to it. So we tell the name of that action here, we'll say walk forward. Right? So this code will run, the code over here will run if we're pressing the forward button. So velocity dot, and let's see, what do we want? So go to 3D view. So our z-axis is the blue one. So if we increase it, the player goes this way. Decrease it, the player goes that way. So if we want to walk forward, then we're going to decrease the z. Minus equals. We'll talk about a, walk speed. Call it 25 buck. And so we don't want to get too complicated with the movement, so we'll say when we press the key, the velocity is just a set value, so we'll call it negative walk speed. Right. That way the player moves at a constant speed when the button is being pressed. elif, that stands for else if. So if we're not pressing forward, but we are pressing walk backward, then we set our velocity on the z-axis to a positive value that makes us move backwards. Else, that means we'll execute this when we're not pressing either of those. We'll set velocity.z to 0, so we're not going anywhere if we're not pressing any keys. So we're going to do the same thing with the x-axis, so we can move horizontally. We'll call it walk right, walk left. Alright, let's run it, see what works. WSAD, whoa. You can see we don't go through the walls when we run into them. Man, we can even jump off a cliff. And of course we go at the speed of sound. That's because, we drop off the ledge very quickly because our velocity on the y-axis has been, it keeps building up while we're on the ground. So it's like we're falling, like we're not moving, but we're still falling. And when we walk off the cliff, all of that accumulated velocity just comes at once. So you just shoot down. So we want to prevent this, just for a better player experience. So luckily, the kinematic body has a handy function called isOnFloor. So you can just say, if we're on the floor, set our y velocity to 0. And that alleviates that problem. See? Much more smooth. In fact, if we want to get frisky here, we're going to add some jumping. Jump. Velocity. We'll call that 100. Why not? So if we're on the floor and we press jump, what do you want to happen? What do you think? Right? If we want to go up, we set our velocity on the y-axis, right? We'll set it to a positive value. Jump velocity. Oh, wow. Now that is those are some strong legs we got there. Let's increase our gravity, or let's decrease our jump. I'll increase gravity. Well, we're still jumping too high, so I'll bring this down to 50. That's reasonable. You know, still pretty high, but you know, this isn't realistic. This is like colored cube land. We don't need to worry about realism. So let's look at what there is to do next. So generally in a first-person shooter, you can turn around. That's a pretty important feature, so let's work on that. So the thing is, our camera is going to be rotating independently of the player itself because, you know, the player node is this capsule, and if we look up, we don't want our capsule to be like flopping around. So, going to attach a script to the camera so it can do its own thing. We'll call it FPS Camera. Whoa. Time to hack. Underscore process. Okay. I'm going to put this keyword here just as a placeholder. So there's another function you can use in your script called ready. This is called at the start of the game, basically. And here I want to go, let's see, input dot cursor. I'm forgetting. Mouse, was it? Cursor. Input dot lock grab set grab. Okay. There's this handy documentation built in, so set cursor. Let's look here. Really? That's weird. So what I'm looking for is a function that will take our mouse and sort of lock it into the center of the screen. This might be it. Okay, yeah. So we've got input, set mouse mode captured. That means we can move our mouse around all we want and it won't like hop off the screen. So that way we can use the mouse to move the camera and click around, and the cursor won't go flying off and making us click on our desktop or whatever. So now what we want to do is we want to rotate the camera based off of how much we move the mouse. So I'm going to keep track of the camera's yaw and pitch. So that's yaw is rotation on the y-axis here, like this. pitch is rotation on X, like this. And those are the only two axes we want to rotate on, because the mouse has two axes, right? You can go left, right, up, down. So we want our camera to rotate on two axes. We don't want that third axis interfering, or we'll get dizzy. So let's go. I'm going to keep yaw, set it to 0 for pitch equals 0. Actually, we can set our yaw to whatever our current rotation is. So transform dot rotation. There we go. Do we want it in degrees or radians? Call it rotation dot y. Right, so pitch equals rotation dot x. Okay. So now we want to say when on every frame we want to say take our yaw. We're going to add input dot mouse let me remember. Mouse hee-ho mouse position. Right, we do. So okay. So we want to get our mouse position. We want to rotate the camera based off of how much the mouse moves, not necessarily where it is, right? So we got to keep track where the mouse was last frame and where it is now. We take the difference, and that determines where we're rotating the camera. So keep a variable for previous mouse position. I'll call it pmouse. It's going to be a vector 2, so that's x and y. So at the end of our process function, we're going to set it to get mouse, or get viewport dot get mouse position. And so we're gonna say our mouse movement is our current mouse position minus our last mouse position. Right. So our yaw, we're gonna increase it by that mouse movement on X, so left and right. We're gonna multiply it by our sensitivity, call it 0.25. And now we changed the yaw variable, but that's not actually the yaw that our camera is at. We gotta set it. So set rotation. So set rotate. All right, we're gonna say rotation equals, and that's vector 3. So we're gonna say yaw, well, pitch for X, yaw for Y, 0 for Z. Let's see how that works. So now we see we are facing a different direction. It's not really the direction we want, and our mouse movement does not seem to affect anything. So, how long have we been going here? 30 minutes? Not too bad. So, let's see what we need to do. To solve problems, you need to debug your script. So, there's tools to do this. For instance, put a breakpoint here, then it will run the game until it reaches this line of code, then it'll stop and let me look at it. So you can see our mouse movement is actually very large. And when I go to the line where we set our rotation, right, you can see our node properties here for the camera. So rotation is 0, 0, 0. But if I move over to this line, you can see our rotation changes drastically. So yeah, that's kind of weird. What's our P mouse? Ah, yes, it hasn't been set. So we're to go here again. And our P mouse is, okay, reasonable, right? Our yaw is stuck at 128. It's not changing. So let's continue our program. Yeah, there we go. So we're still not rotating, which is odd. Perhaps it is such that the mouse isn't actually moving at all. I'll print out that mouse movement to the console and see what happens. Yeah, you see it's always 0. So that means we're going about this the wrong way. Whoops. That's why we're practicing. All right. So I've got a better idea for you. We're going to write this function called unhandledInput. And so this is going to be called when various devices are being, buttons are pressed, mouse is moving, input events. It'll tell you about them in this function. So if event is input mouse motion. So if we got a mouse motion again event, then we can say event.speed. And this will give us, the amount that we're moving the mouse. So it's basically what we were trying to calculate ourselves. And we'll just say, we'll put it into our variable mouse movement. So see how that works. Well, we're at least facing the right direction. That's a welcome change. However, our mouse is still not doing stuff. So I'm wondering, let's uncapture this mouse. You can see it's moving. However, if I'm leaving the mouse still, it's like going crazy. It's going nuts. So what's the matter? Let's turn that sensitivity down so we can tell. I notice when we're switching directions. Ah, okay. What? What in the world? So when we're at the center, start slowing down and then huh. That's game development for you. Let's see, What is speed? Oh, we actually want this, the relative position. Let's see if that helps. Okay. So we're still rotating, but it's a lot more manageable, and it's like responding to the direction that we move the mouse. Of course, it's going the wrong way, so we're gonna change that to a subtraction. You can see we continue to rotate after we move the cursor and stop because our motion of the mouse is setting this, and then nothing's setting it to 0 when we stop moving the mouse. So what we want to do is, after we're done using this variable, we're going to reset it. Alright, now that's more like it. So we're going to uncomment this line of code so that it will be ran. So now we don't see the cursor. And that's pretty good. And you may notice that our movement, when we press W and S, it's moving in this one direction, but it's not moving the direction we're facing. So we want to change that. So we need to go back into our player code for the movement. So now we got to make our walking relative to where the camera is looking. There's going to be some math involved, so don't strain your craniums too much. You can learn this on your own later, but let's see. First, we got to get our camera. So we can access the camera node from this script by doing #camera. I'm going to get its rotation. It's Y rotation, because if we're looking up, we don't want to walk up. We want to stay on the ground. So we're only looking at the yaw, the Y rotation. And actually, so I'm going to make a variable called movement. It'll be a vector 3. And I'll tell you what, I'm going to replace velocity with movement here. So now movement is the vector relative to the camera that we want to move. And then we got to shift that direction. We got to transform it by the camera's rotation. Right? We got to shift it around. And then that's our velocity. So I'm going to take movement, and we'll normalize it. We don't need to do that yet. So we take our camera, and I'm actually going to access transform.basis. And so our rotation is just a number, degrees, right? But our transformation has a component called a basis. It's a matrix. And So our rotation angles are actually being put into this matrix, and that's what the program is using. But what we can do with the matrix is we can multiply our movement by this matrix. And then we can call it trans movement, right? And so this will rotate that movement vector in a direction of that the camera is facing. So want to make sure it doesn't change the y of our velocity, so we're just transferring the x and z components over to our velocity. Like this. So let's see. Hey, look at that. We are triangling. We are fangling. All right. So now we gotta look up and down. These ain't the doom days. We gotta look up 6 degrees of freedom. So we'll change the pitch. We'll add our mouse movement.y to it. Like so. So now it's wrong direction, so alright, now we're looking up and down by changing the pitch. Woo. But you might notice, if you keep looking up, you're gonna look upside down. It's a little wonky. So maybe we can not do that. So what you can do, you can say, you can use this function called clamp. It'll take your number and it will basically keep it from going beyond these two values. So it can't be smaller than negative pi, and then it can't be larger than pi. I'm going to change that to pi over 4. That's about 45 degrees in both directions. Pitch is an angle in radians, so that means 360 degrees is 2 times pi. Alright, so now we can look up and down, but we can't break our necks, so that's good. Now we can move on to something else. So, do you want power up or do you want trap? I'm a big fan of death myself, so let's go for a trap. Now, what kind of trap will you see in a first-person shooter? Usually there's other guys standing around shooting at you, but actually that's quite complicated. I don't know if we have time. We have about 15 minutes to go. So let's think of something real simple. What would be a trap? A first-person shooter. We could do spikes. Actually, no, let's do a gun. That's a power-up, right? Let's do a gun. We'll have a gun that you can pick up, right? So we're going to make a little... I don't know. We are running out of time a little bit. Guns are worth it. Alright, so what's our gun gonna be? Gonna make a little sphere. Gonna make a little cylinder. We'll call that a gun. So this mesh instance node, it just, it draws a 3D model. We're going to give it a cylinder mesh, right? And we're going to say, oh, we can give it a little cone, actually. Yeah. Woo. Okay. Let's do like 0.25. And we'll give it a material. Big black one. Gonna make it real. Gonna make it real metallic. Real shiny. Woo. Not that it actually makes a visual difference in this environment, but yeah. There we go. So now we're gonna call this, well, call it gun model. So now we've got this shiny cylinder. We don't want to do anything with it yet because we're gonna need some way of touching it. So we're gonna call this. What do we want? Want an area? Do we want an area? I guess we do. Area. So that's a 3D. That's what you use for like trigger boxes, right? Like we don't want the player to interact with it physically. We just want to know when the player is in it, right? So we add a collision shape to that. Sphere. Shafir. Good. Gonna make it a bit big. Put our gun in there. So we'll call this the gun. Gun. Our gun model is gonna be right there in the center. Let's reset that transform. We're gonna rotate it because you know, it doesn't look very gun-like. Actually, I'll duplicate our mesh and I'll rotate it some more. Scale it down. So now we have a little grip on it. It actually looks more like a hairdryer than a gun, but you know what? Hairdryers are cool, somewhat. I'd shoot someone with a hairdryer. So we'll put that in our house, right? Gonna add a script to it. So we'll actually call this gun pickup. And we're gonna save this model node structure. Gonna save it as a scene. We'll call it gun. Gun model. That way we can reuse it later if we need to. So we're gonna get gun pickup script. And what we want to do with this, we don't have to spin around because that makes it stand out, right? So we call rotate Y, some speed times our time passed. We'll call this 20. See how that looks. Oh, that's too fast. Alright, so we've got our gun here. We run into it, nothing happens. We haven't told it to do anything yet, so we can detect collisions with an area by connecting a signal. So a signal is just a little message that, you know, it's a little message that a node will send to just relay information. So we use this connect function and we're going to say body entered. This is a signal that the area fires when a physics object enters its collision. So then we're going to connect that to a function on ourself, on our own script, called onBodyEnter. Gonna make that function down here. So it gets a parameter telling us which body, right? We're gonna make sure that's the player. So we're gonna say if body.name equals player. And if you want to remove a node, you call this function on it called queueFree. This will delete it after all the scripts have run, so it doesn't interfere with any of the code. So now we run into it, goes away. So now we want to put it in our hands. We don't want to carry it around. So what we want to do is we want a version of our gun model that's like following the camera, right? So where's our player? There it is. I'm going to take that gun model we saved. So this is actually a scene of its own. So every node is technically its own scene. It's kind of weird, all right? Some transcendental, existential stuff. You can think about that while you meditate, but for now, we're going to bring it into our camera. So it's a child of the camera so that it moves with the camera. I'm going to make it a bit smaller so it isn't covering our face. Turn it around the right way. All right, look at our camera preview. We can move our gun around. We'll have to use the menu because we can't see our little arrows. So I guess we're left-handed. Why not? Gonna make it really wide, really thick. Oh yeah, thick. Okay, never mind. Turn it. There we go. That looks good. So now we got a gun in our hand, right? But we don't want a gun in our hand because we haven't picked it up yet. So what we want to do, we want to keep this gun invisible until we pick up the gun from the level. So we need to handle that in a script. So what I'll do in our gun pickup script, we're going to say when we hit the player, right, we're going to emit signal. We're going to define a signal. We'll call it picked up. And yeah, we're going to emit picked up. So now we'll assign this pickup to a group. Call it pickups. And this will allow our camera to access, you know, we can have a bunch of gun pickups around here, right? And if we want them all to work, we got to make them part of this group. And then our camera script is going to access this group, right? So we're going to say get tree dot get nodes in group. We're going to call it pickup, right? Then we're going to go through each one. So for there, I'm going to call it node in. So this construction will just go through each node in that group and execute this code for each one, calling it node. So we'll say node.connect pickup. So this connects the pickup signal for each of these nodes to our self, to our camera script, and it's going to call a function called onPickup. Pickup. Alright. So when we pick up, first of all, we want to get our gun model, set its visibility to false so we can't see it, and then when we pick it up, we want to make it visible, like that. So now we don't have a gun, get this pickup here, nothing happens. Let's see what went wrong. Let's put a breakpoint here. You see, so didn't see our breakpoint, so that means this code didn't run. So my guess is, let's see, it's not finding this group. That's because the group is called pickups, not pickup. Okay, that's a goof. That's a real goof right there. Alright, so we do that and nothing. We got some more errors. Let's look at that. Really? Non-existent signal. Oh. This happens a lot. Okay. I got the name of the signal wrong. There we go. Hooray! So we can pick up the other guns, but it does nothing because we already have it. And we can test it. Any of these will work. And yeah. Hey, we're making good time. Let's add a funky sound effect. Alright, let's go to Audacity. Shut up. Here's our wacky sound effect. Alright. Dope. Dope. Put that WAV file in our dev folder. There we go. We're going to call it gunget. Yeah. Gunget. So now it's over here. Look at that. This is all of our game assets in our folder. Oh yeah, professional grade. So we want the sound effect to play when we get the gun, so I'm going to attach another node to the camera. We're going to call it audio stream player. And we're going to set its audio stream to our sound here. If we check this, we can test it. Yep, very nice. So we can call this gun get sound. In our camera script, when we get the gun, we can go to our gun get sound node and we can call play on it. So wow, nice. And yep, that's all we have for today, folks. Thank you for coming. We'll be doing things later. It's pretty neat, eh? See you around.